This video discusses another problem on differentiation using the first principles. So the problem is, using the first principles, show that d by dx sine x squared is equal to 2x times cosine x squared. We need to differentiate this problem using the first principles. That means we cannot simply go ahead and use the chain rule and obtain the answer. We have to establish this result from the basics using the first principles. When we say the first principles, we can use the right-hand differentiability or the left-hand differentiability. I'm going to go ahead and use the right-hand differentiability, which is d plus at x equals x. This is equal to limit as delta x approaches to 0. On the numerator, we have f of x plus delta x minus f of x. All of that's divided by delta x. Now we need an f of x. Always for the problems using the first principles, the function f of x is the given function to be differentiated. Therefore, in this example, it should be sine x squared. After that, we can easily write down f of x plus delta x. F of x plus delta x should be equal to sine x plus delta x, everything squared. Now we can simply go ahead and substitute those two things on the right-hand differentiability equation. The equation we have is d plus at x equals x is equal to limit as delta x approaches to 0. On the numerator, for this problem, f of x plus delta x is equal to sine x plus delta x, everything squared, minus f of x is equal to sine x squared. In the denominator, we have a delta x. We cannot do the direct substitution of delta x equals 0, because in that case, this term is going to be just sine x squared and that minus another sine x squared. The numerator becomes equal to 0, and that has to be divided by delta x, which is once again 0. 0 divided by 0, undefined. Therefore, we need to go for further simplifications. Before doing any further simplifications, I'm going to go ahead and expand x plus delta x, everything squared, using a plus b, everything squared expansion. If you still remember a plus b, everything squared from college algebra, this is equal to a squared plus 2 times ab plus b squared. With a equals x and b equals delta x, I can easily expand x plus delta x, everything squared. So this is now equal to limit as delta x approaches to 0. On the numerator, I'm going to have sine x plus delta x, everything squared, should be equal to x squared plus 2 times delta x plus delta x squared. And then we have minus sine x squared. All of that has to be divided by delta x. Now we need to do further simplifications. We have to obtain the difference of two sine terms. For that, we can use sine a minus sine b identity from trig. We know that sine a minus sine b is equal to 2 sine a minus b over 2 times cosine a plus b over 2. With a equals all of this part and b equals x squared, we can apply sine a minus sine b identity in order to simplify the numerator of that limit problem. Then we get this is equal to limit as delta x approaches to 0. On the numerator, I need to have this 2 at the beginning, 2 times sine a minus b over 2. Our a is x squared plus 2x times delta x plus delta x squared. Our b is x squared. So a minus b should be equal to x squared plus 2x times delta x plus delta x squared minus x squared. That means these two x squared terms will be gone. Therefore, that first term should be equal to just 2x times delta x plus delta x squared, and all of that should be divided by 2 times cosine a plus b. This is our a, this is our b. A plus b divided by 2. So it will be x squared plus 2x times delta x plus delta x squared plus x squared. All of that has to be divided by 2. So x squared plus x squared will be simplified to become a 2x squared. And then we have plus 2x times delta x, and we have a delta x squared term. All of that has to be divided by 2. And in the bottom, I have a delta x term. Alright, now we need to do some further simplifications. If you look at this term right here, it is a sine term, and we will see if we can do some further simplifications with that. From that part, I can factor out a delta x. When I do that, this is going to be equal to limit as delta x approaches to 0. On the numerator, I have a 2 and sine. Let me open big brackets. From all of this, I'm going to factor out a delta x. Then I will have a delta x. Open parenthesis, I will have a 2x plus another first order delta x. All of that has to be divided by 2. That times cosine, we have 2x squared plus 2x times delta x plus delta x squared. All of that has to be divided by 2. In the bottom, I have a delta x term. Now I need to do some further modifications and apply a result from trig limits. The result from trig limits that I need is limit as u approaches to 0, sine u over u equals 1. Please note that when you apply this result, whatever the figure right here should be the exact same figure in the denominator, and that figure should go to 0. So I need to do some modifications for this problem, especially for this part of that problem, before applying this theorem. This is the modification that I'm planning. I'm going to multiply the denominator by 2x plus delta x over 2, and I will multiply the numerator also by exact same thing, which means on the denominator I will have a 2x plus delta x divided by 2 term, and on the numerator also I will have a 2x plus delta x divided by 2 term. I didn't change the question given because all of this is in the denominator and all of this is on the numerator, multiplying both top and bottom by exact same thing. Or in other words, it's just like multiplying this given thing by 1. Alright, now we can do some further simplifications. This limit problem is now equal to limit, I will still write just as delta x approaches to 0. On the numerator, we can do some further simplifications actually. The 2 right here can be simplified with this 2 right here. So those 2 2's can be cancelled. So on the numerator, I have sine brackets delta x times 2x plus delta x over 2 times cosine 2x squared plus 2x times delta x plus delta x squared. All of that has to be divided by 2, and all of that times we have this term 2x plus delta x. So let me write that down. All of that times 2x plus delta x. All of that has to be divided by, in the denominator, I will write down all of these as just one quantity, delta x times we have 2x plus delta x divided by 2. Now, sine of this angle is the exact same figure in the denominator as well, which is a good sign because I have this part of the trig limit theorem already constructed. What I still need to do is that this same figure should go to 0. If that can be established, then I'm done. We know for this problem, we have delta x approaching to 0. If delta x is approaching to 0, what can you say about delta x times all of this part? That should also approach 0. Therefore, that part is also now taken care of. We can write down this delta x approaches to 0 part implies that delta x times 2x plus delta x over 2 also approaches to 0. Now we have sine a figure, exact same figure in the denominator, and that exact same figure is approaching to 0. Therefore, I can apply this theorem from limits. That means this part right here should be equal to 1. That means for the rest of this function, I can do the direct substitution of delta x equals 0. When I do that, this limit problem now becomes equal to, we have cosine all of this part, and I'm going to put 0 for delta x in that part. Then it will be just cosine 2x squared over 2, because this term is going to be 0. This term is also going to be 0. Cosine 2x squared over 2 simplifies to become just cosine x squared. So this is equal to cosine x squared, that times we have this part, which simplifies to become just 2x when delta x is equal to 0. So this quantity has to be multiplied by just 2x. Now we are done. This is equal to 2x times cosine x squared. In fact, this is what we wanted to prove. The problem was to prove using the first principles that d by dx sine x squared is equal to 2x times cosine x squared. We just completed this proof. I hope you understood this proof. If you have any questions, please feel free to let me know. Thank you so much.